All right, so let them run around for a bit. So what do we're doing Boyle's law, right? So your form is down there, okay. So what are we holding constant?
Holding constant temperature.
Temperature and what else?
And
Well, you're already holding what else constant by not adding any more particles.
the particle count.
Yeah. So basically, and your amount of moles is constant because you're not going to add any more. So once you add some, as long as you don't add any more, you're holding it constant. So we're good there. All right. So we're good there. You've already placed them. Good. Use the handle. Okay. Change the volume. Now, before we even look at all that, by you making it larger, what should you see for the volume?
By the.
But when you made the container, you increased the volume, what should happen to the pressure without even doing any work?
It drops.
It should drop, right? Because what kind of relationship is it?
Inverse.
Inverse. There's the whole key. So notice as soon as you hear me say pressure goes up, volume must go down, right? And then vice versa, right? Good. Go ahead.
Pressure as the volume changes, it decreases. And then as the volume goes up, the pressure goes down.
Perfect.
This is an inverse relationship.
Exactly. And what should your graph look like?
Curve.
That curve, yes. So just kind of draw it right here on the side, just so you remember.
So, pressure.
Good. Yeah, and it doesn't matter if you have these mixed around.
Yeah.
Usually, I like for pressure to be here, but it doesn't matter. It doesn't matter how you do it. It's still going to look the same. So, thank you, sir. So we increased, right? So make it small again real quick. Just so we can draw that picture. Okay. So draw that picture. Just do like maybe 5 of them.
And then the pressure increases, so they'll be moving faster.
Okay.
And then with larger volume, they have more space to move around, so they won't be going as fast.
Yeah, I don't think the speed changes. I think they're going the same speed. It's just that they got more room to roam in, which deals with the pressure. Because notice now, watch, make it bigger again, like you did earlier. Notice how they're still moving because they still got the same amount of energy. So you haven't changed the temperature. Therefore, they're not going to go faster because you have not added any energy, right? So the temperature, the speed of them is the same. The only thing that's happened is they just got more space to roam. And what that does is less collisions, right? With the what?
With each particle. Like, they don't.
Well, where does pressure come from? From them hitting the what? The walls of the container. So notice if they have more room, more area to hit, your pressure is going to go down. And that's really what it all comes down to. Good. So what's it saying down at the bottom?
Experiment by changing the number of species, volume, and pressure. What combination do you need to blow the top off? Higher pressure and lower volume. Right?
Yeah, so let's try to see if we can. So just like you said.
Make the volume smaller. And
Well, you don't want to add any more because what you just did is you changed the moles, right? We don't want to do that.
okay.
So technically what you said was correct. Notice we would just try to keep pushing, keep making our container smaller, and that's going to keep increasing the pressure until you what? So notice when they don't have any more room, they start saying we're gonna blow this top off. Yeah. So that's the whole idea.